Problem 100 in chapter 5. Here we have a disk which is rotating on ground without any slipping. And the velocity of the center is 3 meter per second to the right, but acceleration of it is 5 meter per second squared to the left. And the question has two parts. What is the velocity of this point of the disk, point A, and what is the acceleration of point B at this moment? Okay. So this is a rigid body. We know acceleration and velocity of O. To find the velocity of any other points of it, if I know the angular velocity of the disk, then I'm going to be able to find it because I can write the relative velocity equation between that point and point O, right? So we need to find the angular velocity. And same thing for acceleration, we need to find the angular acceleration of the disk. So the disk is rotating in this direction because the velocity is to the right, and we need to find omega. If you remember in previous sections, we proved that whenever you have a disk which is rolling without sleeping, velocity of the center of the disk is going to be r times omega. Velocity is 3, and the radius of the disk is 0.4. From here, we are going to be able to find omega. Omega is going to be equal to 3 divided by 0.4, so 7.5 radian per second. And the direction of it is clockwise. Okay, that's omega. And also, in the same way, we proved acceleration of the center is equal to r times alpha of the disk. So because acceleration is to the left, alpha of the disk is going to be in this direction, right? So acceleration of the center is 5, r again is 0.4 times alpha, and from here we are going to be able to find alpha. 5 divided by 0.4 is going to be 12.5 radian per second squared, and the direction of alpha is counterclockwise. So that's alpha. After finding omega and alpha, now I can find the velocity and acceleration of any other points of the disk. For example, to find the velocity of A, we can write the relative velocity equation between A and O. Velocity of A is equal to velocity of O plus the relative velocity of A with respect to O, which, if you remember, is going to be equal to omega cross OA. So we know the velocity of the center, we know omega now, and we can write OA in the vector form. So let's do that. Velocity of O is 3 in the I direction. This is my I direction. And omega, it is 7.5 in clockwise direction. So it's going to be negative 7.5 K, right? So negative 7.5 K cross product to OA. So we need to write this vector OA in a vector form, which is going to be 0.4, the radius, times that direction, which is negative cosine of 45 in the I direction plus sine of 45 in the J direction. Here we have a cross product. We need to do that cross product. K cross I is J, K cross J is negative I. So if you do that and add this 3I to it, velocity of A will be equal to 5.12 in the I direction plus 2.12 in the J direction, and the unit is meter per second. Now for acceleration, in the same way, we we can write the relative acceleration equation between B and O. So let's do that. Acceleration of B is equal to acceleration of O plus the relative acceleration, which we just talked about it. It has two components, alpha cross R, which is OB here, plus omega cross OB, or negative omega squared times OB. So we know what is OB in a vector form. We have omega, we have alpha, so we have everything here. So we can just replace everything here to find the acceleration of B. So AO is 5 in the negative I direction, so negative 5I. Alpha is 12.5 counterclockwise, so positive 12.5 K hat. Cross product to OB, and OB is just simply 0.2 times I hat. And negative omega squared, negative 7.5 squared times OB, which is again 0.2 times I hat. We have a simple cross product here. K cross I is J, so by replacing that with J and adding everything together, acceleration of B will be equal to negative 16.25 in the I direction plus 2.5 in the J direction meter per second square.